Good morning. I hope everyone is doing really good today. We're going to move on to the second lesson in Chapter 8, Lesson 8.2, Multiplying and Factoring. So today we're going to teach you how to multiply with monomials, binomials, trinomials, and then we're also going to teach you how to factor these guys out. So today you're going to need some paper, a pencil, your textbook, page 492, basic calculator, and homework 68, which is online. Again, really short, not a whole lot of homework there to do. Just want to make sure you guys have got the basics. Alright, so we're going to go ahead and get started. Alright, here we go. Our first example is going to be multiplying a monomial and a trinomial. So remember, a monomial is one term, and a trinomial is three terms. So here we have a monomial, one term, negative 1x cubed. So I'm going to put that 1 right there so we don't forget about it. Negative 1x cubed times a trinomial, one term, two term, three terms. So you have learned distributive property already this year. You have learned in Chapter 7, we multiply, we add exponents. So we're going to use all those rules that we've already learned to do what we're going to do here. So we're going to take this negative 1x cubed, and we're going to multiply it times this positive 9x to the fourth. Then we're going to take this negative 1x cubed, and we're going to multiply it times the negative 2x to the third. Then we're going to take our negative 1x cubed, and we're going to multiply it times this constant of positive 7. So all I have done is showed you our distributive property, and I wrote them out. Negative 1x cubed times 9x to the fourth. That's what this represents right here. Then I did negative 1x cubed times negative 2x cubed by showing you this here. Then we'll do negative 1x cubed times positive 7, which I showed you that right here, negative 1x cubed times positive 7. So we're going to go ahead, we multiply our coefficients first, then we do the variables. So we're going to do our coefficients first. Negative 1 times positive 9 is negative 9. Remember, when we have variables involved, these both have an x. So to get our new exponent, we add 3 plus 4. So what is 3 plus 4? That's right, 7. So this becomes negative 9 to the 7th. Alright, so we do the same thing, multiply the coefficients. Negative 1 times negative 2 is a positive 2. Then they both have the variable x, and this exponent is 3, plus this exponent, which is 3, and 3 plus 3 is, bam, beautiful, 6. So 2x is 6. Alright, fantastical. Then we take our next coefficient of negative 1 times the only coefficient we have, which is the constant 7. So negative 1 times 7 is negative 7. And then we just have the lonely x to the third, so x to the third just comes along for the ride. There's no exponents to add, so it just stays negative 7x to the third. Then we check. We know that because we start with the highest degree to the lowest. 7, then 6, which is lower than 7, then 3, which is lower than 6. So 7, 6, 3. Highest is 7, and on to lowest, which is 3. So this is our final answer. Alright, so now we're going to do the same thing for the second one. Alright, so here we go. We're going to take our 5n on the outside and multiply it by the first term, which is 3n to the third. Alright, our 5n is positive, so positive 5n times our second term, which is a negative, and that's 1n to the second. So I want to go ahead and put that 1 in there, so I know it's a negative 1. And then I got a positive 5n on the outside, so plus 5n, times my positive 8 on the very end down there. So again, I'm showing you 5n times 3n cubed, right here. I'm showing you 5n times negative 1n squared here. And I'm showing you positive 8 right down here. So we're going to go ahead, we're going to multiply our coefficients first. So I've got 5 times 3, which is 15. They both contain the variable n, so n. This has a coefficient of 1, an exponent of 1 that I don't see, so 1 plus 3. So what is 1 plus 3? Beautiful, 4. So 15n to the 4th. Alright, here we go. So coefficients, 1 positive 5 times negative 1. Yep, negative 5. They both have the variable n. This has an understood exponent of 1. So then I've got 1 plus 2. 1 plus 2 is, beautiful, 3. So negative 5 and the 3rd. Then I multiply. 5 times 8 is a positive 40. And we just have the single variable, so it comes with us. And there's no exponents to add, so it just stays plus 40n. We check to make sure it's in standard form. 4, then 3, then 1. So it goes from highest to lowest. It's in descending order. Beautiful, we're done. Alright, so we're going to go ahead and move on to the next one. So here's our last 4 we're going to try on this section before we move to the next example. Alright, so here we go. We're going to take our term on the outside, which is a positive 7x, and we're going to multiply it by the first term, which is a positive 1x. Since this is a positive 7x, I'll put plus 7x, and I'm going to multiply it times the second term, which is a positive 4. So again, I'm showing you 7x times 1x right here, and I'm showing you 7x times 4 right here. So we go ahead, we multiply our coefficients first, and then our variables second. So 7 times 1 is 7. They each have an x, and they're understood exponents of 1. So we've got 1 plus 1, which is equal to, that's right, 2. So 7x squared. Then we multiply our coefficients. 7 times 4 is a positive 28, and we just have the variable x. There are no exponents to add, so it just comes down 28x, final answer. And we check to see if it's in standard form, of which it is. Degree of 2, degree of 1, so it's going down. Alright, we're going to go ahead and move on to the next one. Our outside term is 3m squared. We're going to multiply it by the first term, which is 10. It's a positive 3m squared, so plus 3m squared. And we're going to multiply it times the second term, which is m. So plus m, a positive m. So I've got 3m squared times 10, and 3m squared times a positive 1m. So again, we'll make sure you understand it's a positive 1m, positive 1m. Alright, so multiply the coefficients together first. So 3 times 10 is 30. And then the only variable we have is an m squared, so it comes with us. 3 times 1 is positive 3. And then they have the variable m, but this has a degree of 2 and an understood degree of 1. So we have to add those exponents, 2 plus 1. So I don't do anything with this 30m squared because there's no exponents to add, so it stays m squared. 2 plus 1 is 3, so 3m to the 3rd. Now I have to check to make sure they're in descending order. Well, 2 is not bigger than 3, so I have to rewrite it. That's a positive 3m to the 3rd, so positive 3m to the 3rd. And then my positive 30m to the 2nd. So now I'm in descending order. Degree of 3, degree of 2. Beautiful. Alright, so here we go. We're going to take our first term, which is a positive 4x, and we're going to multiply it by the first term, which is 2x to the 3rd. We'll take our positive 4x and multiply it by our second term, which is a negative 7x squared. We'll take our outside term, our monomial, positive 4x, and multiply it by our last term, which is a positive 1x. So I'll put that 1 right there so you can see. So now we're going to show you this. Again, I did this, 4x times 2x cubed, then 4x times negative 7x squared, then 4x times a positive 1x. So I did all 3. Multiply the coefficients first. 4 times 2 is, beautiful, 8. They both have the variable x. This has an exponent of 1 that we see, so it's understood 1, so 1 plus 3. 1 plus 3, that's right, 4. So 8x to the 4th. Alright, so now we've got positive 4 times negative 7, which is a negative 28. They both have the variable x, understood exponent of 1, and 2. So 1 plus 2, beautiful, 3. So negative 28x to the third. Then we do positive 4, positive 4. They both have the variable x, and both have a degree of understood 1. So 1 plus 1, which is, beautiful, 2. So 4 plus 4x squared. Degree of 4, 3, 2. Descending order, that is our final answer. Alright, so our last example on this section, we're going to take negative 8x, y to the third, and we're going to multiply it by the first term, 7y squared. We'll take our negative 8y to the third, and we'll multiply it by our second term, which is a negative 4y. We'll take our negative 8y to the third, and multiply it by our last term of negative 1. So I'm showing you negative 8y to the third times 7y squared right here. Then I'm showing you negative 8y to the third times negative 4y right here. Then I'm showing you negative 8y to the third times negative 1 right here. Alright, so we're going to multiply our coefficients first. Negative 8 times positive 7 is negative 56. They both have the variable y, and we add their exponents when we multiply. So 3 plus 2, beautiful, 5. So negative 56, y to the fifth. So we're going to do negative 8 times negative 4 is a positive 32. They both have the variable y, and then we're going to add those exponents. So that's a 3 plus an understood 1. 3 plus 1 is, beautiful, 4. So 32, y to the fourth. Then we're going to multiply negative 8 times negative 1, which is a positive 8. And we only have one variable, and that's the third power. So bring him down because there's no exponents to add. So then our final answer, it's in standard form for degree of 5, then 4, then 3. So beautiful, beautiful. Alright, so we're going to go ahead and move on to our next example. Alright, we're going to go ahead at this time and do example 2, which is going to be finding the greatest common factor. So we have to first understand what a greatest common factor is. A greatest common factor is when we look at our coefficients and then we look at our variables. So there's two different things. So to do this, you're going to need to find the GCF. That's what greatest common factor stands for, GCF. Greatest common factor, GCF. And we want to see if we can find the one of the variables. And then we take the two and we put them together to get one GCF. Alright, so I'm going to teach you how to find greatest common factor in case there's something you haven't learned along the way in math, which is no big deal because I'm going to teach it to you today. Alright, so to find the greatest common factor, we first have to find out what are the factors of each number. So for our coefficients, we want to first identify who our coefficients are. So our coefficients are 5, positive 25, and positive 45. So I'm going to write this off to the side here. 5, 25, and 45. Alright, so those are our three coefficients. Factors are going to say to us, what can I multiply together to get those individual numbers? So if I look at 5, what can we multiply together to get 5? Beautiful. 1 times 5. We know 1 times 5 is 5. That's not too bad. So we're going to ask ourselves, what can we multiply together to get 25? Well, we can multiply 1 times 25, and we can multiply 5 times 5 to get 25. So far, so good? Alright, so to multiply to get 45, we can do 1 times 45. It's not divisible by 2, but it is 3. So 3 times 15 is 45. It's not divisible by 4, but we got 5 times 9 is 45. It's not divisible by 6, 7, or 8. Then we already hit the 9 and we're done. So here are our factors. So now we're going to look and see what they have in common. So we're going to circle the numbers that they have in common. So this factor has a 1, this one has a 1, and this one has a 1. So they all have a common factor of 1. Beautiful. So now we're going to see what else they have in common. So I'm going to write that down. They have a common factor of 1. So we'll put that up here, 1. Alright, so now this one, the only factor this guy has left over is a 5. They have a 5, they have a 5, and they have a 5. So they all three share a 5. If you notice that the number 5 has no more factors, that means they all three can't share a 25 because there's no more 25s, and they all three can't share a 9, a 15, or a 45 because there's no more factors up here. So the only two numbers that you see in all three sets of factors is a 1 and a 5. Well, we'll never use 1 as the greatest common factor because if we divide by 1, we are right back where we started with. If I divided all of these by 1, they'd still be 5, 25, 45. So outside of the number 1, the only number they have in common is 5. So their greatest common factor of the coefficients is 5. Now we have variables. To find the greatest common factor of the variables, we first have to identify that they are the same exact letter, like A, B, C, or D, etc. So our letter happens to be an X. So this one has an X, this one has an X, and this one has an X. So our three variables that we have are x to the third, x to the second, and x to the first. So when we find the variables, we find the one with the lowest exponent. So who was lower? 3, 2, or 1? Beautiful. So then our GCF of our variables is just x, or x to the first. The reason we picked the smallest one, because remember when we divide, we subtract those exponents. So if I do 3 minus 1, I get a positive number. If I do 2 minus 1, I get a positive number. And if I do 1 minus 1, I get a positive number. But if you were to try to pick 3, well, 1 minus 3 is going to give me a negative number, and we don't want negative exponents. So when we are finding the greatest common factor with variables, we always pick the variable with the lowest exponent. So now that we know what we have, we're going to identify our greatest common factor. So we take the coefficient, which is 5. So we'll bring this up here, 5. And then we take the variable and we put them side by side. If one of them are not there, then we just use the 1. So once now we know what they are, we divide each term up here by our factor. We divide this by 5x, this by 5x, and this by 5x. Alright, so here we go. Our final answer. We always write down the greatest common factor first, so 5x, and then we put in parentheses what we get afterwards. So divided by 5 is, let's write 1. I'm going to put this exponent here. When I divide, what do I do to these numbers? That's right, I subtract. Minus 1 is 2. So I get 1 x second. So again, I got this by doing 3, take away 1, gives me 2. 5 divided by 5 is an understood 1. Alright, so online, if you type in a 1, it's going to mark it wrong, just so you know. So we're going to do the next one. Positive 25 divided by positive 5 is a positive 5. Then we put the exponent of 1, so 2 take away 1 is, let's write 1, so just x. We do not put an exponent of 1 right here in the computer. It will mark it wrong on your online homework. Alright, so positive 45 divided by positive 5 makes a positive 9. And then these are exponents of 1. So 1 minus 1 is, let's write 0. So let's look at that, x to the 0. What does x to the 0 equal to? That's correct, 1. So 1 times 9 just makes it 9. So this would be our final answer right here. Alright, I know that could be a little confusing, so we're going to try Nutter Butter. I want to make sure you get this. Alright, so to find our greatest common factor, we have to find the GCF of the coefficients and of the variables, if there happens to be one. Sometimes there is, sometimes there's not. I'm going to show that to you. So we're first going to take our coefficients, which are 3, 9, and 12. Those are our three coefficients. I don't have to worry about whether they're positive or negative because I'm just dealing with what can I multiply to get them. So what can we multiply to get 3? Beautiful. 1 times 3. What can we multiply to get 9? Fantastical. 1 times 9 and 3 times 3. And what can we multiply to get 12? Fantastical. 1 times 12, 2 times 6, and 3 times 4. Alright, so here are all of our factors. So the one factor that we're never going to use is 1 when we look for GCF. Where's my other one go? There it is. Okay, so we're never going to use the 1 for our GCF. So now find the coefficient with the least amount of factors. So this has, outside of the 1, 12 has 1, 2, 3, 4, 5 factors. The 9, outside of 1, has 1, 2 factors because 3 repeats, so a factor of 3, the 9. Then the 3, outside of the factor of 1, it only has a factor of 3. So we're going to check to see, I see a 3 here, a 3 here, and a 3 here. So they all have a 3 in common. It's the only factor they have in common. So that makes 3 the GCF for the coefficients. Then we look at our variables. Has an x, has an x, has an x. So they all have to have the variable. Everybody in the polynomial, trinomial, binomial, whatever, they all have to have the same variable in order for you to write it down. So the first term has an x to the fourth, the second term has an x to the second, and the last term has an x to the first. So I'll put a first here. So remember with the variables, it's always with the lowest exponent. So we get 4, 2, 1. 1 is the lowest, so just x to the first, making my GCF of this 3x. So that's my GCF. Alright, so I'm going to take my GCF, 3x, and bring it down. And then I'm going to divide everybody up here by that GCF. Divide the first term by 3x, the second term by 3x, and the last term by 3x. Alright, so here we go. So 3 divided by 3 is, beautiful, 1. So we'll go ahead and put these little exponents of 1 up here. But all these unknowns. So then I get my new exponent, 4 minus 1. Beautiful. So I'm going to have 1x to the third. So 3 divided by 3 is an understood 1. 4 minus 1 makes 3. So I got negative 9 divided by positive 3, which makes 3. And 2 minus 1, that's right, it's just 1. Then I got negative 12 divided by positive 3, which is negative 4. And 1 minus 1 is 0. And we know that x to the 0 is equal to 1. And 1 times 4 still is at 4. So this is my final answer. You always have to put your GCF on the outside and then show what you got left over on the inside. Alright, so we're going to try these last final 3 and move our way down. Bring these guys up slowly so I'm not trying to make your eyeballs go squish squish in your head. Alright, we want to find our GCF. And we got a first digits and then the variables. Alright. So we write down our numbers that we have. Our coefficients are 12 and our constant is 20. So we'll write these down. Coefficients are 12 and the constant is 20. So now I've got to find what can I multiply to get these numbers. So we did 12 earlier up there. So we said 1 times 12, 2 times 6, and 3 times 4. So to get 20, we can do 1 times 20, 2 times 10, and 4 times 5. So these are what we can multiply together to get 20. Which factor do we not consider when finding GCF? That's right, we do not consider the factor 1. So now we're going to circle the factors they have in common. So this has a 2, and this has a 2. So they both have a 2. Both have a 2. 2. This has a 3. This does not have a 3. This has a 4, and this guy has a 4. So they both have a 4 in common. This has a 5. This doesn't have a 5. This has a 6, but this doesn't have a 6. They've got a 10, but they don't have a 10. They have a 12, but they don't have a 12. They have a 20, but they don't have a 20. So the only factors they have in common are 2 and 4. Beautiful. So who is bigger, 2 or 4? 4. So 4 would be the greatest common factor of our coefficients. Then we go look at the variables. Well, this has a variable x, but this doesn't have a variable. That means there is none. There is no GCF for our variables because both terms do not have the variable x. So in order to have a variable, they all must have the same variable, and 20 does not have a variable. So therefore, we can't have a GCF for the variables. So all we have left to be for our GCF is just our coefficient, which is 4. Alright, so that's our GCF. Beautiful 4 GCF. So we're going to take our GCF and divide the first term by that and our second term by that. So here we go. We bring down our GCF, which is 4. Open our set of parentheses, look this up. So 12 divided by 4 is, that's right, 3, and then we just have the x. Then we got positive 20 divided by positive 4 to positive 5. Final answer. Beautiful, beautiful. Alright, let's try next. So to find our GCF, we got to find it of our coefficient and our variable. Boop, 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 boop. So if we look at our coefficients, we got 45, then we got 27. Alright, we did 45 earlier, then we had 1 and 45, 3 and 15, then we had 5 and 9. And then for 27, we've got 1 and 27, 3 and 9. Alright, so which coefficient do we not deal with when finding GCF? That's right, the factor we don't deal with is 1, so we don't have to worry about him. So 45 has a 3 and 27 has a 3. So that's one factor they have in common, so 3. 45 has a 5, but 27 doesn't. 45 has a 9, and so does 27. 45 has 15, but 27 doesn't. 45 has a 45, but 27 doesn't, and 27 has a 27, but 45 does not. So the only factors they have in common are 3 and 9. Who is greater, 3 or 9? Correct, so 9. So 9 is our coefficient GCF. So now let's go to our variables. Alright, so this has a variable b, but does this have a variable b? Nope, no variable. So it means they don't both have a variable, so there is no GCF for the variables. So our only GCF that we have is 9. And we'll take that 9 and we'll divide it by each term by 9. So I bring down my GCF, which is 9. Then I divide. 45 divided by 9 is 5. And I bring down my variable b. And then positive 27 divided by 9 is positive 3. Final answer. Beautiful. Alright, our final one. On this example, GCF, we got coefficients and variable. Alright, so first I got to identify our coefficients. They are 4, 12, and 28. Alright, 1 times 4, 2 times 2. We've done 12 already, so we'll go ahead and write this down. 1 and 12, 2 and 6, 3 and 4. To get 28, we got 1 and 28, 2 and 14, 4 and 7. Which factor are we not going to consider for GCF? We're not going to consider the factor 1. So we'll start with the next factor, which is 2. 4 has a 2, 12 has a 2, 28 has a 2. So they all have a 2. I'll repeat the 2 again because it's the same factor. 4 has a 4, 12 has a 4, 28 has a 4. So they all three have a 4. So they both have a 2, they both have a 4. Well, there's no more factors here to check, so therefore we have to stop. Between the two, the greatest one is 4. So 4 is our GCF for our coefficients. And now to do our variables, we look to see x, x, x. They all three have an x. So the degree with the lowest is there's 3, 2, 1. So 1 is lowest, so x to the first is my GCF. So my GCF would be 4 and then x. So that's my coefficient and my variable. So I take that and divide each term by that positive 4x. Remember, I always bring down my GCF first, and then I divide. Okay, so we're going to finish it out. I'm sorry, my thing moved on me. My bad. All right, so we divide. 4 divided by 4 is 1. We'll go ahead and put these understood exponents of 1 with those. And 3 minus 1 is 2, so 1x squared. So we just write that as x squared. Positive 12 divided by 4 is a positive 3. And 2 minus 1, that's right, is a positive 1. And then negative 28 divided by 4 is negative 7. And 1 minus 1 is 0. And we said x to the 0 is equal to, correct, 1 times 7 stays the same. So this would be our final answer right here. Alright, so we're going to go ahead and move on to our next example. You guys are doing fantabulous. I am so proud of you guys. Keep it up, man. Okay, this is the final thing that we're going to do. It's nothing new. It's everything you've already learned. I'm just going to ask you 2 questions. This is what you'll see on the homework when you go online. One section is going to ask you, what is the GCF? So if they say, what is the GCF? They don't want you to factor it out. They don't want you to go down. They do not want you to go all the way down to here. They just want you to find the GCF. How we found the GCF to be 5x, we found it to be 3x, we found it to be 4, then 9, then 4x. That's all they're looking for. They're not wanting you to go all the way down and divide everything out. They just want you to determine what is your GCF. So remember, to find our GCF, we have to find it of the coefficients, and then we have to find it of the variables. Alright, so those are the 2 things that we're looking for. So we first have to identify who are our coefficients. If you don't see a coefficient, it's an understood, correct, 1. So our 1, 24, 12, and 4. So now I'm going to give you a little hint. Anytime 1 is one of your coefficients, you will not have a GCF for your coefficients. So they're none, because it's an understood 1. That means if I divided this by 1, I'd get 1. If I divided this by 1, I'd get 24. If I divided by 1, I'd get 12. If I divide by 4, if I divide by 1, I still get 4. So I don't have a number other than 1 to be my GCF, because the only factors of 1 is 1 and 1. That's it, so it's just 1. And remember, we said we don't use 1s to find the GCF. So therefore, they'd have nothing in common outside of 1. So then we want to move to the variables. We got a g to the 4th, a g to the 3rd, a g to the 2nd, and a g to an understood 1. Alright, so remember we pick the lowest exponent, which is here, g to the 1st. So our GCF for a variable is just g. So the answer to our question is the GCF. The answer would just be g. That's all they're asking for. Now if they say the polynomial, when they ask us to factor, I'm going to bring this up just a smidge. Factor means they want you to, which up here is g, and then they want you to divide each term by the g. That's what factor means. So factor says they want you to find the GCF, and then they want you to divide. And I'll make a little note here, by the GCF. So they're showing you to factor. It means factor means pull out this. Tell me what you pulled out. So if my GCF is a g, that means I factored out a g. And after I factored out a g, I got something left. I took a g away. I divided the first term by g, I divided the second term by g, the third term by g, and the fourth term by g, which we did already. I've already showed you this. So we're going to divide. So since it's all 1, all these coefficients will stay the same just as. Will stay 1, 24, 12, and 4. And I'm going to go ahead and put the understood exponent of 1. So when we divide, we do what to those exponents? That's correct. We subtract them. So 4 take away 1 is 3. So g to the 3rd. We keep the same coefficient of 1, so that means 24. 3 minus 1 is, beautiful, 2. Keep the coefficient because 12 divided by 1 is 12. And 2 minus 1 is 1, so just 1g, so g to the first. And 4 divided by 1 is still 4, and 1 minus 1 is 0, so it means we no longer have a variable, and this would be our final answer. So this is when you're factoring, you have this whole big thing. When they just want the GCF, you just write what the GCF is, what you get from the coefficient and what you get from the variable, put side by side. All right. That is the end of our lesson today. You just have a few problems online tonight. So I know you guys can do this. Again, please stay up with this because we're going to be really busy all week long. We got a lot to do because you have to know all of this stuff as you move into Algebra 2 next year. You have to know this. So please do not cheat your way through this. Please, I beg of you. Have a good night.